Welcome to MRL. In this learning session, we'll be learning the application of trigonometry, exercise 9.1 of 10th NCERT CBSE textbook. Now, before we proceed with the solutions of the examples of exercise 9.1, I would like to suggest you all to read the example, read the statement, read the statement clearly, part by part, understand the statement and write down what is given to you in that statement and what you have to find in the statement, and also to draw a neat diagram, which depicts, which clearly indicates the parameters given to you and what you have to find. So that is exactly the procedure what you have to follow. Unless you don't understand the statement, you will not be able to solve the example. Understanding the statement is 50% of the solution. Next 25% is to write down what is given, what you have to find in the diagram, and hardly any percentage is left for getting the solution. So please follow this procedure in solving all the examples of trigonometry. Okay, now let us proceed. Now we are given in the first example, there is a pole, and to that pole and to the ground there is a rope tied, but very stretched across the pole and the ground. There is a point C on the ground. There is a rope of 20 meters length. That's what is given here. Length of the rope is 20 meters, and the angle which the rope makes with the floor is 30 degrees, and we have to find the height of the pole AB. So we have to draw the diagram here first, and when you draw the diagram, AB is the pole, BC is the ground, AC is the rope stretched, which is 20 meters in length, and angle of elevation is given as 30 degrees. We have to find the height of the pole, so we have got a right angle triangle here. Now the diagram is very clear description of the statement of the example. Now we have to find the height, and it's so very simple. Now if you observe here, we want h is unknown, 20 meters is known, so a relation which relates AB and AC has to be sine theta. There is no doubt about that. So take 30 degrees, sine 30 degrees. Now sine 30 degrees is AB by AC, so half sine 30 degrees, you know that sine 30 degrees is half. And please remember the the specific angles value chart, and with the help of that chart, or make a chart yourself. I have already told you how to make a chart, a simple chart. Find out the angle of sine 30 degrees, that is half, and AB is h and AC is 20. So 2h is equal to 20, h is equal to 20 by 2, h is equal to 10 meters. The height of the pole is therefore 10 meters. So very simple. In this example number 2, we are given a tree which breaks at a certain height, and the broken part touches the ground, making an angle of 30 degrees. The distance between the foot of the tree and the point where the tree touches the ground is 8 meters. Now we have to find out the height of the tree. Now the example is very clear. There is a tree, that is AB. AB is a tree here. Let us take the height of the tree as capital H. Then it breaks at point D and falls onto the ground. The tip of the tree touches the ground at point C, which is 8 meters from the foot of the tree. Now we have to find out capital H, that is AB. Now let us assume that the point where the tree breaks, BD, is small h. Now we have to find out AB. Now how to find AB? So let us understand this. Now the diagram of the description is as shown in the figure, as I have told you. Now we have the two right angle triangles formed here. One is ABC, the other one is DBC. Now let us relate BD and CD here. Let us relate BD and CD. Now we know that BD upon CD is sine 30 degrees, and sine 30 degrees is equal to BD upon CD, but BD is h, so therefore I have taken BD as h. But what is CD? CD is the AD here, because the part AD is nothing but CD, because the AD only has fallen, therefore CD and AD are equal. Therefore AD is capital H minus small h, because AD is AB minus BD, that is capital H minus small h. Therefore we have, if I cross multiply it, then we have h minus h is equal to 2h, or h is equal to h plus h, or capital H is equal to 3h. That is equation number 1. Now if you take the small triangle, that is DBC, angle B is 90 degrees, and DB is small h, and BC is 8 meters. So we can apply tan 30 degrees here, because BD upon CB or BC is tan 30. So tan 30 is equal to h upon 8, and that is tan 30 is 1 by root 3. 1 by root 3 is equal to h upon 8, or h root 3 is equal to 8, or h is equal to 8 by root of 3. but we have to find capital H. Capital H is equal to 3 times H. Therefore H is 8 by root 3 here, 8 by root 3, that is H is equal to, by what you call rationalization, we get H is equal to 8 root 3 meters. So for the height of the tree AB, that is equal to 8 root 3 meters. Try to remember that. Now coming to the next example, example number 3, we are given 2 slides. The one slide is used for the children below 5 years, and that is the height of that slide is 1.5 meters, and another slide is used for elderly children, and the height of that slide is 3 meters. The first slide makes an angle of 30 degrees to the floor, and the second slide makes an angle of 60 degrees to the floor, as I have shown in the diagram. Now we have to find out the height of the the first slide and the height of the second slide. So let us go one by one. Now let us take the slide of the children below 5 years. Now if I take the length of the slide as L and the height of the slide as AB, now we are already given the height of the slide. Okay, we have to find the length of the slide here. So L is equal to, we can find sine 30 degrees. If I take sine 30 will be H upon L, and that is equal to sine 30 is half 1.5, that is H is 1.5 and L is not known, we have to find. So L is equal to 1.5 into 2, that is L is equal to 3 meters. Therefore please understand here we are asked to find length and not the height, because height is already given to us. And coming to the next example, again take sine 60 d. Sine 60 will be H upon L, and sine 60 is root 3 by 2. H upon L is 3, that is H is already we know it is H upon L. H is given as 3 meters, yeah, it is given to us. So 3 divided by L, so or cross multiplying root 3, L is equal to 3 into 2, or L is equal to 2 root 3 meters. So for the length of the slide for 5 years and below is 3 meters, length of the slide for elderly children is 2 root 3 meters. It's a very simple example. Now coming to the next example, we are given a tower. There is a tower here, BC is the tower, and there is a point A from the foot of the tower at 30 meters. Point A is at 30 meters from the foot of the tower. From point A, the top of the tower makes an angle of elevation 30 degrees. So we have to find the height of the tower. So we have drawn a right angle triangle here, ABC. H is BC is the height of the tower. So I have taken it as H, and relating BC and AB, we have to take tan 30. So tan 30 degrees is equal to H upon 30. Tan 30 is 1 by root 3 is equal to H upon 30. That is equal to root 3 H is equal to 30. H is equal to 30 by root 3. Rationalizing, we get 10 root 3 meters. So therefore the height of the tower is 10 root 3 meters. Now the next example, that is example number 5. We are given a kite. The kite is flying at a certain height, that is height is given as 60 meters. Now there is a string tied to the kite and it is stretched, and when it is stretched to the floor, it makes an angle of elevation of 60 degrees. Now we have to find the length of the stretched string here. So now let us draw the diagram here. AB is not known to us, of course. AB is not known, H is known, and L. So we have to relate BC and AC, because since I know H here, BC and AC has to be related, and to relate that I can take sine 60 degrees. So sine 60 degrees is equal to H upon L, and it is root 3 by 2 is equal to 60 by L, or cross multiplying root 3 L is equal to 60 into 2, or L is equal to 60 into 2 divided by root 3. Rationalizing, we get and simplification, we get 40 root 3 meters. So that is the length of the string, and the length of the string is 40 root 3 meters. So try to remember that. Now coming to the next example, we are given an example here that there is a boy whose height is 1.5 meters, and he stands at a certain distance from the building. That is, there is a building here and he stands at a certain distance, let us say point A here, and from point A he observes the tip of the building, the top of the building, and it is makes an angle of elevation of 30 degrees, and when he moves from A to D to the next new position, he makes an angle of elevation of 60 degrees with the top of the tower. So reading the statement and making the diagram, we get two right angle triangles here, that is ABC and DBC. Now we have to use these two right angle triangles to solve the examples. Let us see how to do. So if we take the triangle ABC, then tan of 30 degrees is equal to BC by AB, and BC is equal to 30 minus 1.5, that is 28.5 meters, and AB is x plus y. The distance which the boy walks is taken as x, and the distance from the new position of the boy and the foot of the building is taken as y. So it will be, the total distance will be x plus y. So it is 30 minus 1.5 divided by x plus y, that is 28.5 divided by x plus y, that is equation number 1. Now let us take the next triangle DBC. Now in triangle DBC, if I have to relate BC and DB, I can take tan 60. So tan 60 is equal to BC by DB, and DB is y, and therefore it is again 28.5 divided by y, that is equation number 2. Now using these two equations, we can solve for x. That means if I take here equation number 1, that is x plus y, cross multiplying, x plus y is equal to 28.5 into root 3, and we have got the value of y here. Y is equal to 28.5 divided by root 3, putting the value of y here and simplifying, we get x is equal to 28.5 into root 3 minus 28.5 by root 3. Taking 28.5 outside, we get root 3 minus 1 by root 3, and that is 28.5 in the bracket 3 minus 1 divided by root 3, and that is 28.5 into 2 by root 3 into the root 3 by root 3, and we can rationalize this rather. I have rationalized it here. Therefore it is 28.5 into root 2 root 3 by 3. Simplifying, we get 19 root 3 meters, and that is what is the distance moved by the boy when he from point A to point D, when the elevation changes from 30 degrees to 60 degrees to the top of the what you call building or the tower. Okay, now understand that. Now coming to the next example, we are given angle of elevation of top and bottom of a tower is 45 degrees and 60 degrees from the ground, from the point A on the ground, and the elevation, the top of the tower elevation is 60 degrees, and the foot of the tower elevation is 45 degrees. Let us understand this. We are given a building of height 20 meters, and on that there is a tower, and the tower is CD. From a point A, the top of the tower is at having an elevation of 60 degrees, and the foot of the tower is having an elevation of 45 degrees. Now we have to find the height of the tower. So let us understand how to do this. Already I have drawn the diagram here. We have two right angle triangles, ABC and ABD. Now if you take the triangle ABC, then I can relate the distance x with BC by taking tan 60 degrees. So tan 60 degrees is equal to h plus 20 meters. I have taken the height of the tower CD as h here. So h plus 20 meters divided by x, and that is equation number 1. Now if you take the triangle ABD, then triangle ABD is that means tan 45 degrees is equal to BD by AB, that means 20 by x, and tan 45 degrees, as you know, it is 1, and therefore 1 is equal to 20 by x, therefore x is equal to 20 meters. Now using these two equations, we can solve for the small h there. So now root 3x, multiplying it, root 3x is equal to h plus 20, and x is 20 here. Root 3 into 20 is equal to h plus 20, or h is equal to root 3 20 minus 20, or 20 root 3 minus 1 meters is the height of the tower. That is the answer given in the textbook. But otherwise you can simplify it further and find out, take the value of root 3 as 1.73, simplify, you get 14.6 meters is the height of the tower. Now coming to the example number 8, here there is a pedestal. Please understand, there is a pedestal and its height is not known, that is h, and there is a statue on the pedestal of height 1.6 meters. From the pedestal, from the center of the pedestal at a distance of x meters, from a point A, the angle of elevation of the top of the what you call statue is 60 degrees, and the foot of the statue is 45 degrees. Now we have to find out the height of the pedestal. Already the statue height is given as 1.6 meters. Let us understand. So we have two right angle triangles here. Right angle triangles say there ABC and ABD. Now if you take triangle ABC, the height 1.6 meters plus h, I take the relation as so BC by AB I can take. Therefore tan 60 will be BC by AB, and that is 1.6 meters plus h divided by x, and that is equation number 1. Now let us take the triangle ABD. Now if you take triangle ABD, then BD upon AB is tan 45, and that is h upon x, and tan 45 is 1, therefore we get x is equal to h. Now if I cross multiply, this will be x is equal to h plus 1.6 by root 3, and x is h, replacing x by h, we get h is equal to h plus 1.6 divided by root 3, and taking root 3 h here, and root 3 h is equal to h plus 1.6, and taking h to the left, we get root 3 h minus h is equal to 1.6, or h in the bracket root 3 minus 1 is equal to 1.6, or h is equal to 1.6 divided by root 3 minus 1. Rationalization, taking the conjugate of root 3 minus 1 and simplifying, we get 0.8 in the bracket root 3 plus 1 meters is the height of the statue. Further simplifying, taking root 3 as 1.73, we get approximately 2.18 meters is the height of the statue. So that is how we can solve the examples. That is the procedure of solving the examples. Understanding the trigonometric ratios, that is the application of trigonometry. So to solve these examples, we have to just read the statement, understand the statement, draw a neat diagram, and then apply the one of the trigonometric ratios which gives you the unknown value, and find it out. So learn them, practice them, note down them in a book, and so that they can be used as a reference for your future use. Okay, thank you.